Good evening, ladies and gentlemen. We are Team So Green, which stands for Suburban Optimization of Green Roof Efficiency and Economic Inquiry. I'm Ben Borchers, this is Sri Sinha, and Kenny Hunsley. And these are the other members of Team So Green, and we wish Matt Delp feel a lot better. He's home sick right now. We wish him well. Our mentor, Dr. Andrew Ritzby, and our librarian, Alex Carroll, who we'd like to also thank for all their help and support. So today we'll be talking about the problem of stormwater runoff and how it is damaging in society today, and our proposed solution to the problem, which involves green roofs. Also research questions about how exactly to implement these green roofs and what specifically we will design, which goes into our methodology and our processes for designing these green roofs. We will discuss our current results, such as the data we are currently collecting, and the team logistics, what went behind all of this building and testing to really culminate to where we are now. So some background and why stormwater runoff issues are very important in society. So impervious surfaces are anything that does not absorb water. So shingles, any kind of roofing materials that are gravel or asphalt on the ground. More and more impervious surfaces equals more and more surface runoff, especially in storms, hence stormwater runoff. In large cities, stormwater runoff is a very large issue, and it's costing Marylanders millions of dollars a year in damage because of this idea of peak flow after a rainfall, where water is being channeled into the drainage systems that run parallel to the sewer systems in many of our cities, and the water will then overflow the drainage channel into the sewage channel and then travel to the sewage treatment plant, where this waste cannot be completely treated, and the overflow gets dumped into large bodies of water such as the Potomac. This water has not been treated. So we have a green roof solution, which is traditionally implemented on completely flat roofs with about a 2% grade to have a little bit of drainage, and this can absorb up to 100% of rainfall, thus reducing this peak flow rate and saving our waterways. So going into our research problem, there's really a lack of sloped green roof systems. There are for specifically built roofs that are engineered to withstand the extra weight, but we're looking at super lightweight, extensive, which means really thin, green roofs that can be put on a slope. So how can we design the best retrofit green roof to be placed on existing sloped roofs? And we're defining best as the roof that has the least amount of weight but has the most amount of water retaining capabilities. As you increase the slope, water wants to run down it. So we're going to try to maximize water retention. And also, how appealing is this to homeowners? We can't just come up with a design and no one want to use it because it doesn't look good. So what we believe we'll be able to accomplish is that we'll be able to maintain a 10 pounds per square foot added extra dead load, dead meaning it's not moving, it's always there on the roof, so the roof can still hold snowfall and whatnot. So we're keeping this dead load very low while still absorbing water similar to that of a flat green roof system. Also, that these green roofs that we design will actually be more appealing than shingled roofs, so consumers will purchase them. And I'll hand it off to Sri.
Great. Thank you, Ben. So in designing our research, there are two specific, as Ben touched on, there are two kind of venues that we're looking at. So one part of our methodology is looking at specifically the modules and the green roof system itself. And then the other part of our methodology is looking at kind of the social consumer side and really getting in touch with homeowners to see if this is viable. So to first touch on the green roof side, we started our methodology by first designing these modules. As you can see, we've got 4 different modules, and they're up up by the Comcast Center greenhouses, so if you ever drive over that way, you can see them peeking out up there. We started off by testing our substrate, which is the base layer, one of the many layers that are in the green roof system. So for that substrate, we had to do a number of tests to try to keep our weight down. So we did wet and dry weight tests. We're looking at how long that water was retained and what the rate of water release is. We're looking at the durability of different substrate components and trying to decide which one's the best one, as well as testing it in different conditions, looking at freeze and thaw tests. As we got into our actual experimental design, we made it very clear that we're trying to control for anything except for the slope being what we're really testing for. So we've maintained the same substrate depth of 2 inches, the same plant varieties, and the same green roof layers in all of our 4 modules. So we've got modules at 15 degrees, 30 degrees, and 45 degrees, with a control that's at 2 degrees, which is, as Ben mentioned, the standard for what is a flat roof. And now that we have this all set up, we are happily collecting data. So the things that we're looking at the volume of rainfall. So anytime it rains, you can think of us, we're happy, we're getting some data. We send out a happy little group text that's like, yeah, we're getting data right now. So we're looking at how much the rainfall is, what the moisture content is when within the green roof modules, how much is retained. We're looking at plant coverage overall. We want to have happy, healthy plants to see where they thrive and how much coverage they have. And we're also looking, obviously, at how much runs off, how much rainwater is coming off of the platforms, and what that rate is. We've divided our methodology for the test into 2 phases. The first phase is just the green roof systems themselves, just letting the water run off. And then in the second phase, we will integrate a system to collect that water, to store that water. So you can either use that back in a pump system, or you could imagine for a regular homeowner, they might be able to take that water and use it as a gray water system to water their plants or to wash their car, to really try to make the most of that precious water that we have. So that's basically our methodology for the green roof side. Now looking at the focus groups, that's also split into 2 separate phases. The first phase has already been accomplished. That was back in spring of 2013, earlier this year. So we're reaching out to homeowners to see what their current knowledge levels are, what kind of misconceptions they might have about what green roofing is, because it's certainly more than just sticking some plants on your roofs. So we're trying to look at what they know already and get some insight into our design. So as we go forward, we can really see what folks are concerned with as they might consider implementing a green roof on their own home. Then coming up, we're going to have our second focus group in fall of 2014. So after we've got about a year's worth of data and we've really seen how our green roofs are working, we want to go back, invite back our old participants, but then also invite new people to come in to share their opinions now that they've seen the data. They can get some pictures. We can provide some more specific numbers for them to look at and really ask, how is this designed? Is it working for you? How can we best market it? And what are your concerns at this point as we continue to go forward and design?
So, our present research. We have currently done testing in the spring on the components of our green roof, particularly the substrate. We finished testing with an aggregate called Gemstone, and unfortunately we had some results from that, but it was unable to be produced anymore, so a discontinued product allowed us to not use this, but to use a more standard product of M2, which is an industry mix. And so we used that and added some Greek pumice into it to take out some of the heavy particles and to add a more lightweight particle system. So as you saw on the last slide, we have built our modules. They're 12 foot by 4 foot, and they contain 6 layers. EPDM is a standard layer of waterproof membrane for a roof. They're usually found on commercial roofs, and they're used, in this case, to be the bottom layer to keep water from seeping under the roof. We then have a drainage layer to drain any extra water that might come through the substrate, through the green roof system. Then we have filter fabric, and then rock wool. It's a little backwards there. But Then above that stuff, the rock wool is basically a layer of insulation type material, which is good for retaining more water without adding a lot of weight. In addition to that, we have geocell, which is a slope retention grid, normally used for erosion control. In this case, we're using it as our substrate retention grid and keeping our substrate from falling down the roof on these slopes. So we have 2 inches of substrate then above the rock wool, and our plants are then planted in that substrate. We have planted and we have probes installed and collecting data. As you can see, we have some temperature data there. We also have some moisture content. We're working on getting our rainfall data installed, but right now we're collecting data. And things are kind of showing us what we would think. Higher up is retaining less water and has a lower moisture content, whereas lower down on the roof, indicated by the top line there, is a more moist area. So, as Sri said, in spring 2013 we completed our first focus group. Some of our findings are that cost is a large deterrent. Green roofs cost more than traditional roofs, and if they don't have a lot of benefit, then homeowners aren't going to buy them. So that goes into the resale value of property. People are saying, what will my neighbors think? Oh my God, it's a green roof. Like, is that something I want? Is that going to make it go, my value of my house go up or down? One thing that has attracted homeowners, though, is the possible money savings from adding the insulative layer on top of your roof can save energy costs and heating costs during the summer or winter. So here's a typical quote that we found. If it saves us money, like with an electricity or heating cost, I think we'd do it, especially if it wasn't too expensive. But I'm not going to go out of my way and do something expensive. It's my bottom line that I have to consider. So some challenges we faced this semester was finding time. We're all juniors, we all have busy lives. Even over the summer, it was really hard for us to get together and build things. And so it was a lot of everyone chipping in and doing their part to get us off the ground and get our modules built. One of the other things that took a lot of time was finding what supplies to order, their availability, and getting them to us, because a lot of them were in Baltimore or the Eastern Shore, and it took some time. Some challenges we foresee are recruiting for our next focus group. We were able to get members of different Maryland communities out for our first one, and we're hoping to get that again. Our 45-degree module, as you can see here, we kind of had to set it downwards so that we could get on top of it to put things together. And so it'll be rough to see if it'll meet our runoff requirements. Our measurement of weight per square foot is something that we'll solve eventually, but it's currently been eluding us. And we're really worried about weather, because too much rain or too little rain can really affect our plants, and blizzards can also affect our structure. So our team is composed of sub-teams that work all at the same time to do different things. We have a rotating facilitator. Larry is a rotating facilitator, as pictured here. We have different team roles, and we have team norms that are upheld by consensus of the team. So we tried for a very democratic process to keep things rolling and keep everyone engaged. So some advice: set strict standards early on and enforce your team norms. It's hard when you're dealing with your team and they're friends, they're people who lived in dorms with you, you really get to know them. It's hard to say things to them and have a hard talk sometimes, but it's important. Do that. Have someone to resolve conflicts. On our team we have Courtney, and she does a great job of it. You know, it's something that's needed. Do stuff outside of Gemstone with your team. Become friends. We do, at least once a semester, we do a barbecue or something to get food together, and so that keeps us bonded and keeps us enjoying our time working on Gemstone. Deal with problems, and communication is key. We finally found a group text, and GroupMe is so helpful for communicating in both Gemstone-related things and outside of Gemstone. So here's our conclusion. As you can see, we've completed spring and summer summer, fall of 2013. We're right on track. Good luck to all of you in the future. Here are our citations. Are there any questions? Any questions?
That's you.
Okay. In terms of your focus group, how did you contact them and how did you decide what demographics you're going to pick, or you just get where you put it?
Sure. Okay. So when it came to our focus groups, we wanted to look at really who's around us, because green roof systems can be very dependent on the area, right? So we wanted to make sure that we're building for the Mid-Atlantic region. So we specifically reached out to different PG County and Montgomery County homeowners. We did that largely by just canvassing out into the community, different contacts. We got participants from like University Park, that's right there, Tacoma Park, Montgomery County. We also got people from Bowie, a few participants a little bit further out from the Eastern Shore, but just generally around our area to just really try to be representative. Yes.
So has your study included possible ways of maintaining the green roof system for the homeowners that use it? Because I'd imagine that somebody who had the green roof system on their house might not necessarily be eager to climb on top and do any maintenance required themselves.
So the idea behind a green roof system is it can last upwards of 100 years plus, which is one of the advantages compared to a traditional shingle roof. And once it's become established and your sedum have grown and created a complete coverage of that roof, and when you factor in how thin the substrate is and the extreme temperatures on top of a roof, you've eliminated all other plant pallets. So as long as it's raining, you don't need to do anything once you've put it up there. So that's kind of the cool things with the green roof. And we're adding the pump system to create an irrigation system as well. So if in case you're running a little bit low on water, you can just flip a switch.
But in addition to that, we have had, in the focus group, we had heard concerns about leaves and things. And green roofs might not be the best thing to put underneath of a tree because, it would collect leaves and that would be a little hard to maintain. So really, it's one of those things in seeing what's the best system for any given house.
Think more urban areas.
Thanks.
So this pump system is just like using the collected rainwater, basically?
Yeah, so we're looking at using the water collected from the runoff. And so the idea is that it will circulate back through the system, and if it continues to run through the system, then, it'll go back into its container. But after that, it will also evapotranspirate during the cycle. The plants will take it up and will be able to get rid of water in more than just the runoff. Do you have questions?
It seems to me that you have an additional problem, and I don't know if you have plans to study. It has to do with how much energy would you save by adding a green roof. And it is something on which you could do a theoretical analysis, but also you can do measurements of real houses. Yes. Do you have any plans to do that?
So we don't plan to do that in the scope of our research, but there are other studies out there that we would include in our lit review and include in our information sessions for our focus group participants in order to better assess the situation. There have been some studies where they used the cargo containers and put green roofs on them and did different test studies to see how the temperature was affected inside. But there is other research and other generalized consensus that they are used for like heat savings farther up north and things like that.
It's actually quite well studied. There's a myriad of different benefits that you can look at. And what we're looking at specifically is now that it's been established in the scientific community that green roofs are such an incredible asset, we're trying to see how widely we can apply it. So that's really where we're trying to make it be as applicable to as many different homes and surfaces as possible.
One more question.
Getting popular now.
Sorry.
Have you taken into consideration of like any homeowners like aesthetic desires to have
So one of the things is without a pump system, it's easy for areas of a green roof to get dry. So like we said, the top of our green roof is already showing that its moisture content is much lower than the other parts of the roof. And so that is one of the things we're using, trying to implement to make a difference in that moisture content and to keep the roof green. You know, we don't plan on having to, say, add water to this storage system to pump, but in the case that it's not been raining, there's not enough water in the system itself, a homeowner could ideally add that to the system, to the storage system, to keep water in the roof. And so that's part of our design in that, is to keep it green.
Thank you.
Thank you.